We'll see how that final grade is.
What is it? 10 it was 3-10. 3-10. 3-10. If you go to, can you guys do me a favor? Go to 3-10 in DeWalt. I just want to read to you guys Hazardous Location. Really nice 2 pages. Summarize the whole deal. And then I have an 18-slide presentation. I'm going to go run through it. And then I call it quit for lecturing from now until forever for you, unless you come to one of my code classes and then you get punished again. Okay, if you guys look at 3-10, please highlight this one. There are 3 hazardous locations acknowledged by the NEC code book. Class 1, 2, and 3. We have touched on this before, guys. Everybody knows that. 1, 2, and 3. And also they take the class and they divide it into the 2 divisions, Brad. Division 1 and Division 2. So the most important things to understand, guys, is understand what the classes are and what the divisions are. So if you look at class number 1, if I want to summarize it, Spencer, with one word, just one word, to describe class number 1, it will be flammable gases and vapors. That's the word. Huh? One word. Well, 3 words: flammable gases, vapors. Flammable gases and vapors. Okay, really is. Flammable is the main word. Gas and vapor is the second main word. So every location that has a gas or a vapor that's flammable, that will be a class 1. Okay. This is in page 3-10. Really easy. If you guys look at that, summarized in very nice way. And it's covered in Article 501 in NEC code book. Class 1 is 501, covered in 501. So class 1, my friends, is flammable gases and vapors. Class 2, summarized in one word: combustible dust. Combustible dust. And Brad, there's a difference between flammable and combustible. Flammable is more the flash point for the gas is lower. So a gas can ignite at a lower temperature than a dust. That's why they use the word flammable and they use combustible. If anybody's interested, there is a lot of stuff about them. But all what you're interested right now is the word flammable. Anything flammable can ignite faster at a lower temperature than combustible. That's why they rate them. If anybody's interested, why they put them this way. So we have combustible dust. Any dust that could be combustible, they put them in class 2. Class 3 is ignitable. Look at the words they use: ignitable. Ignitable, as it needs more temperature to ignite than to combust, than to flammable, than to the word flammable. So ignitable flyers and fibers and flyers. So that's class number 3. 205, 202, 501, 502, 503 is the article that talks about these 3 classes, guys. From flammable gases and vapors into combustible dust into ignitable fibers and flyers. It's all what you need to know about them. Divisions, Eric, my friend, you can listen to your friend Chad one more time. Divisions are: Division 1, the hazard exists all the time. Division 2, the hazard will exist under abnormal condition, malfunction of equipment. That's it. And sometimes, Brad, the area adjacent to class 1 in a lot of places, they call it also class 2. So if class 1 flammable gas is here, the area directly adjacent to class 1, they classify it as a class 2 because it could, it could have the hazard. Any question, guys, about the 3 classes? 501, 502, 503 are the article that talks about them. Flammable gases, combustible dust, and ignitable fibers and flyers are 1, 2, 3. Normal conditions, the hazard exists under normal condition, that will be class, that will be Div 1, Div 2 under abnormal condition or malfunction of equipment. Can you guys see that? Everybody's okay with this? The second thing that this book has really nice that I like about this DeWalt, it has, Brad, they take the gases and the dust and they group them, the smarter than Chad here, they group these into gases and dust groups. So if you guys look at right underneath, it says class 1, class 2, and class 3. They take the material, dust and gas and vapor, and they group them based on groups. So for example, group A, B, C, D are class 1. These are gas and dust. Gas and vapor, flammable, of course. Class E, F, and G, these are combustible dust. Now you're going to ask me, Chad, what the heck is a class? What is a in the class 1, what is the gases, for example. So they have a nice, what I like about this book, it puts in the second page, guys, had really examples of class 1 gases. What are class 1 gases? If you guys look at class 1 gases, spray booth interior. So do you see the examples that they gave us? That's class 1. That's a gas or a vapor. And a bunch of them, gas generator, rooms, and all these stuff. So I'm not going to read all of them. There are examples of locations and materials right in page 3-11 that has class 1 gases, guys. Class 2, the dust, guys, look at the grain and grain products are class 2. We have dried egg and milk powders are class 2. So in the second page, my friend, and I'll agree to all of them, they're examples of locations, Brad, if they exist. That will be a class 2 location. Okay? Class 3 location, look at class 3 location. There's portions of rain, cotton, or other textile mills. That's the ignitable fibers. There's flax processing plants, clothing manufacturing plants. Most of it is flows related to cotton and clothes in class 3 location. Any question, guys, about the three classes? And examples that you have in DeWalt. This is 310 and 311. Page 310 and 311. Definition of the classes and the divisions, guys, and examples of locations. DJ? Any question, guys, about this? Because that's the key point is. And by the way, code-wise, 501, 502, 503 are the code that talks about them. Now we know the locations, Brad. We're going to go and talk about how to wire in these locations. They put the reason why they shift them into Article 500, guys, because they're special locations and they need special attention when we wire in these places. Any question, guys, about this first? The worst of the worst is Class 1 Div 1. If you have a piece of equipment that can work in a Class 1 Div 1, 99.999, it will work anywhere else because that's the worst of the worst. Okay? Any question, guys, about these 2 pages? I thought to highlight them because it's summarized. If you can read through the article, guys, it's a lot of lingo, but these are really summarize everything that you need to know about it. I'm recording, Mr. Beth. Okay. So the rest of them, I have a couple of pages and pictures, guys, I want to show you about wiring. We talked about different between divisions and groups and so forth. Intrinsically safe system. We'll talk a little bit about intrinsically safe system. Seal, vertical and horizontal seal, difference between explosion and explosion-proof and enclosed and cascaded. So this chapter, guys, talk about how do you wire in these 3 locations. How do you wire? What type of wiring system do you use in these 3 locations? Requirement for luminaires, pendant luminaires, list of conditions for flexible cords. Okay, here's the first thing. This slide, guys, summarize the 3 classes that I talked to you about. It's the last lecture. That's why we went fast this time. Everybody was so excited to finish. Okay, so this, guys, will summarize class 1, 2, and 3 that we talked about, which is flammable gases and vapors, combustible dust, and ignitable fibers and flyers. And groups, the most important thing is the groups. They take in a class 2, 1, and 2, they take different gases and dust and they group them. So Ben is not enough to say this switch gear is rated for a class 1 Div 1. You have to also have group what? Group A has to be also listed for group A gases and dust. So they go by group. Class 1 and Div 1, guys, Div 1 and Div 2, we talked about normal conditions. The keyword I always like under normal condition, and this is the accident. So you guys remember? We talked about Division 1, Division 2, normal condition, the hazard exists, accident, the hazard exists. And the other 3 classes are, the words to remember are ignitable, flammable, and combustible. So, any question, guys, about this? Questions? Mr. Bab? Okay, the key word for class 1 location, guys, is operating at temperature. Then, when you have equipment in a class 1, class 2, and class 3 locations, you don't want the temperature of the equipment to operate at a temperature higher than the igniting temperature or combustible temperature of the equipment. So this is the key word in a class 1 location, Brad. You do not want any equipment to work on at a temperature higher than the ignition temperature of the gas. So if this light, if the ignition temperature of the gas, guys, is say 25 Fahrenheit, well, let's say 40 Fahrenheit, you don't want the temperature of this piece of equipment to be higher than 40. You want it, less than 40 so it doesn't ignite the equipment. In a class 2 and 3 locations, they have tables that have the temperature, they have temperature. The key point, guys, in order to ignite, combust, or create a flame, you need temperature. So the temperature is a big deal for the equipment. You need our equipment, if you install them in class 1, 2, or 3 location, to be the temperature that the equipment is working on to be less than the temperature that can ignite or create the combustion or create the flame of these gases, dust, or flying or flares. Any equipment. Here's a group of, if anybody's interested in group A, what type of a group A location? Read through them. There's a lot of gases, names of gases, guys. Group A, B, C, and D. I believe these were class 1. So all these were class 1, and these 3, I believe, were class 2. Is that what we classify them based on? Let me see, based on 310. Yep, F, G, and H. Yep, class 2. So if anybody want to read and look at the temperature that it takes to ignite, they have a temperature for every equipment. That temperature, if you reach this temperature, that gas will ignite. Yes. Yeah, I thought so. Yep, it's in page, no, not in DeWalt, 247. It's not in DeWalt. So when you're dealing with this, guys, Fahrenheit, if you have this gas, I'm not going to claim to read that one here. Can you guys see if it reaches 581 Fahrenheit, this gas will ignite. Look at group C. There is a group, some of them, guys, the temperature is very low to ignite them. So, you can look at all the temperature that it takes to ignite them. Look at this, 347. You reach that temperature, you created fire in this gas. So anyway, you don't have to memorize that. That's a table how they. So if I say class 1, div 1, group B, this means group B, guys. This means this equipment can be installed in all locations that include these gases. Whatever the gases exist, all group B gases, this equipment is rated for it. Any questions, guys, about this? Questions? Okay. Again, the equipment have to work at a lower temperature. The Smarter Than Chad guys created a system called Intrinsically Safe System. What they do, Intrinsically Safe System is a whole system in the code, guys. They make the equipment work at a temperature lower than that can ignite the area. So if there is a gas here that need 100 degree Fahrenheit to ignite, if I can bring a fixture that can run no more temperature-wise, the surface temperature of it, no more than 50, okay, or 90 degree Fahrenheit, then I guarantee you that it will not ignite the area because it doesn't have enough heat to start the fire. So that's what basically intrinsically safe system. They drain. It doesn't have thermal or electrical energy if it shorts to create a fire. There is no electrical or thermal energy, no thermal or electrical energy to create the ignition, and must be physically separated. If you have a tank, guys, what they do, they have a sensor inside the tank. That sensor right inside the gas, or gasoline or whatever. That sensor will be intrinsically safe system. So if it shorts, if it heats, the temperature, no heat or no short will ignite that sensor inside the gas. That's what basically intrinsically safe system. Any question, guys, about that one? And the good thing about if you use intrinsically safe system, you don't have to have rigid and all this stuff because they don't have energy. They don't have energy in them. Okay, all locations, guys, class 1, div 1 location need, when you wire, Brad, when you start working, this is what you're going to be wiring with. And a class 1, div 1 location and class 2 location, you're going to be using rigid, and that's why people don't like it, because now all my EMT, MC cable out the window, guys. You're going to be using rigid and intermediate or MI cable. There is an MC cable listed, guys, for hazardous location, but you can't use it for a wiring system, just flexibility. So that's where you need to do when you wire in a class 1 and class 2 location, you're going to be looking at what? Rigid, intermediate, and MI. Very important. What makes it interesting? Expensive, more expensive now. More expensive. If I want to wire a room like this, guys, EMP. But if this is hazardous location, now I'm engaged into rigid, and intermediate. Okay. In a class 1 div 1, Spencer, if I decided to have a switch in a class 1 div 1, it has to be explosion proof. In a class 1 div 2, all what it has to be, location must be dust. In a class 2, it has to be dust ignition proof. So if there is a dust right here, this switch has to be dust proof. If this is a class 1 div 1 location, guys, or 2, it has to be explosion proof. I want to show you an example. Now, who cares, Jam? Equipment become extremely expensive when it's explosion proof or dust proof, guys. So explosion proof for class 1, div 1, and dust proof for class 2 locations. What they do, Brad, is they have threaded 5 threads, I think. When they thread the equipment, look what, if there is an explosion inside, this is a circuit breaker, okay? And there's an explosion inside the circuit breaker. What they do, guys, they have 5 threads here. By the time the gas escapes from the enclosure to the outside, it has to go through 5 threads. 1, 2, 3, 4, 5. By the time it goes through all the threads, it will cool down. Somebody's smart enough to figure by the time the explosion and the hot air escape from that enclosure, which is explosion proof, through the threads, 5 threads, and goes all through all the threads, goes sealed, it will be cool enough that's not going to ignite the surroundings. So if I have an explosion in my circuit breaker and there is a gas over here, by the time this air will escape outside, the temperature of the air will be low enough that's not going to ignite the surrounding. That's why they need the threaded, Brad, and hazardous location around all the equipment. So even if there's an explosion inside it, it's not going to explode because explosion proof. It contains the explosion inside it, but the air has to go somewhere. It escaped through the 5 threads, and by the time it reaches out, it's low enough temperature-wise that it would not do any damage to me. So who cares? Aren't they smart, the people who think of all this? Don't you guys think that? Am I the only one who's excited here?
What's the company again that tests all these?
Oh, you mean UL? Yep. You are one of the major companies that does that. Seal. What they do, guys, when you class 1 div 1 location, when you go from one location to another, you have to seal. And there's a couple of examples of a seal. So they don't want the gas to enter a conduit and travel. So if this is a gas station, guys, I don't want the gas to enter the conduit and travel all the way through the conduit right here, all the way to the other side, and then create an explosion in a different room. So they seal them. So seal, minimize the passage of gas. There's horizontal and vertical seals. And
Chico.
huh?
Chico.
What's Chico?
The seal that they usually use for that.
Explosion proof seal. I don't know. Is that what it says the name of that?
No, I just remember.
Yeah. I don't know what the name really. Condensation, guys, if you have a vertical, so you have the seal for passage of gas. They have horizontal or vertical seals. So if you're going horizontal, there's a seal. If you're going vertical, there's a seal. And Brad, if you're going vertical, they have drainage for the vertical. So there's a drainage right here. So if the water actually gets in here, it will drain away, not down to the equipment. So the weep holes and drainage to permit continuous draining. Basically, if you're going up and you block the conduit, then there will be water condensated here. What is, you know what the seal is? They block it. So if the water is contained here, they'll have a seal that allows the water, guys, either weep out, or you can open it and drain the conduits. So seal. Every time you go from one location to another, you have to seal. Let's look at the seal here. Here's where you need a seal, Brad, when you go work, buddy. You need to seal around every equipment that interrupt current. For example, here's a motor. You guys think this could arc or spark? Yes. So you need to seal right here. Look at this. This is a motor controller. Do you think we're interrupting current and using current in it? Yes. So you need to seal around it. The same thing, explosion-proof circuit breaker, around it. And also, every time you leave the explosion-proof area into another explosion-proof area, you need a seal. So this is a class 1, div 1 location. This is no class location. Every time I go from class 1 location to a no class, I have to seal, and also around all equipment that sparks, arcs, and sparks. Here's my question for you, Ben. Had this been a J box, I wouldn't seal around it. There's nothing in the J box, it's just termination. See how this is a breaker. It opens, it arcs, so I have to, so you seal around equipment that interrupt current or consume current. Does that make sense? Just a rule of thumb. And also every time you exit the class 1 location to a different location. Any question, guys, about the seal? Here's a horizontal seal, vertical seal. If it's vertical, you have to drain it. It has to have a drain in it. So when you become a project manager, Ryan, which you are, and you go to inspect the project, that's the things they're going to be looking before the inspector shows up. Class 1, Div 1, do we use rigid? Yes. Do we have seals around the equipment? Yes. If it's vertical, does it have a drain? Yes. Did we seal as we moved from class 1 location to a non-classified location? Yes. You know what I mean? Does that make sense, guys?
A little more control of the seal.
Every device that uses current or interrupt current. So the motor uses current, these interrupt current, right? Why? Because these are where the spikes happen, guys. I want to make sure no gas want to enter the area where there's consumption of power or interrupting of power. And the reason why they seal here, because they don't want the gas to seep through the conduit to another place and explode. Any question, guys? Any question, my friends? Okay, circuit breakers and panels. If you guys, anything in explosion-proof, Brad, look at the panel. If you want to talk about expensive equipment, imagine putting an explosion-proof breaker panel, right? Explosion-proof. You're talking about 5 to 10 times more. If it's 100 amp, that costs you $100. Multiply this by 5 to 10, $1,000 piece of equipment. So equipment become expensive, bulkier, hard to work with. So if you're bidding a job that's hazardous location class 1 div 1 versus non-hazardous location, your multiplier probably, depending where and what the type and all the stuff, between 5 and 5 times more, almost 5 times more. It's going to cost you labor and material to work with this equipment. So that's why we care about these places, guys. So we have class 1 location, determine the enclosure used, explosion proof, and Panelboards for class 2 location. So the key point always they keep repeating, guys, the word in a class 1 location, you need an explosion. Where's my explosion proof? At least in class 1 div 1, in class 1 div 2, most of the time. In a class 2 location, I need dust ignition proof. So if I have, you don't need an explosion proof in a class 2 because we have dust. We don't have gas. So when you have a gas and a vapor, you need explosion proof. When you have a dust, what you need is dust ignition proof. So the dust cannot enter the enclosure and create a fire. Okay, now can I put an explosion proof in an area that needs dust proof, guys? Yeah, no problem. It's more protection. More protection. Okay. Luminaires. There are 2 types of luminaires in hazardous location you guys can use. You can use called enclosed and cascaded. That's the most common one. Enclosed and cascaded. You'll see a lot of picture. Enclosed and cascaded. Vapor tight, but not explosion. Not permitted in a class. Look at that. Not permitted in a class 1 div 1. It's permitted in a class 1 div 2. This is the most important thing, guys. This will be in a class 2 location and class 3 location and class 1 div 2. The cascaded. If you are to install anything in a class 1 location, Brad, class 1, a fixture in a class 1 div 1, that fixture have to be explosion proof. Other than class 1 div 1, you don't need an explosion proof. Class 1 fixtures. Class 1 div 1. So you need an enclosed and cascaded. Looks like explosion proof, but it's not cheaper piece of equipment, basically. Any question, guys, about luminaires? So summarize luminaires. Class 1 div 1 explosion proof luminaire. Other than class 1 div 1, you can get away with cascaded. They call them enclosed and cascaded for class 2 and class 1 div 2 location. We installed a lot of class 2 div 2 location, guys. T-rated equipment, guys. Equipments have lights. When they put lights, guys, luminaires, they have a T rated for them. They will tell you what's the temperature, the surface temperature of this fixture. So by looking at it, if the surface temperature of this fixture when it's up and running, guys, is 100 Fahrenheit, and the ignition needed for this gas is 90, then I can't put 100 in a place where it needs 90 degree to ignite the gas or the dust. So that's why very important. This was actually on the test, just FYI. Temperature rating of equipment, temperature rating of luminaires, T rating. So what's the T rating? Temperature rating of luminaires. Every luminaire will have a stamp on it that's used in class 1, div 1, in class location that tell you the temperature rating of this equipment. There's a page, guys, it's a really nice page that has all the temperature for you. Where is it? It's page 255. So if it has T1 Brad, then if you look at T1, it gives you 842. So the hottest spot is 882. So if the gas needs 500 to ignite it, I wouldn't put a fixture that will be 882 hot in an area that needs 500 temperature to ignite the gas. FYI, so that's basically operating temperature kept below the ignition. This is a key point. Operating temperature must be at all times kept below the ignition temperature of the gas or the dust. Okay, here's how they measure them. We care less about how they measure them. The manufacturers do a lot. In a class, in div 1 guys location, they go by the outer surface, and div 2 location by the hottest spot. They go by the hottest spot on the luminaire. That's how they rate them, by the outer surface. It doesn't have to be the hottest spot or not. Any question, guys, about the T rating? The most important things to know is the T rating of the equipment. If the equipment has a T rating higher than the ignition rating of the gas or the dust, then you can't use it. Here's the table that we're looking at. So, Muhammad, my friend, here's my temperature right here, 844. If the ignition is 800 degree Fahrenheit, I have a gas that needs 800 degree Fahrenheit to ignite it. Can I put a T1 gas in it? No, right? Everybody knows? Because that hottest spot for this T1 rated fixture is 842. It's going to get 842 hot. I can't put it in a place where it only takes 800 to ignite the dust and or the gas or the vapor. Everyone knows that? So every fixture that you guys buy will have a T rated on it. So it's better for us as installers and designers, Spencer. They actually go by class 1 div 1 right at the fixture, so we don't even have to worry. And class 1 div 1 and group. So if I know if the gas is this group, if it says group A class 1 div 1, I can install it in this location for that particular group. Any question, guys, about the temperature rating? So that's the hottest or the hottest spot on the fixture that you can encounter. T rating. Can I use the flexible cords, guys, in flexible cords in a class 1 div 1? No problem. So for example, you are looking at explosion-proof fixture. Look how beautiful it looks, right? I have an explosion-proof couplings, explosion-proof box, and also extra hard cord, extra hard cord. This is typical. We can use this fixture in a class 1 div 1, guys. The fixture is explosion-proof, the cable extra hard cord, and the explosion-proof, the flexible couplings, and everything is explosion-proof, basically. The cord is going to be extra hard. Any question, guys, about this? Now, I can't use the cord to go wire, Brad. I just use the cord to tie to the equipment, When you use the cord, there's a few things that you have to know. Like cords, they have, the cord have to be extra hard that you're using. This is a cord, guys. Everybody knows, I've seen them at Walmart and everywhere else. Contains separate grounding. You have to have a separate grounding conductor in that cord. Be properly connected to the terminal or supply connector, so you have that mesh that holds it. And be supported by clamps and be sealed. You have to seal it, so seal it through the cables. Be supplied with seals to prevent the entrance of the flammable vapors in a class 1 location. And have some type of a seal. Any question, guys, about that one? The question is, can I use a cord in a class 1 div 1 location? No problem. Here's the requirement for it. The fixture has to be class 1 div 1, explosion proof, everything explosion proof, and the cord itself has to be extra hard cord. Motor control, guys, if you use any of these, and I summarize this by any device that you use, Jim, to interrupt the power or consume power, this have to be an explosion-proof device in a class 1 Div 1. And you have to seal around it. That's really summarizing the whole deal. Must be also explosion-proof. The enclosure have to be explosion-proof. The devices are the same devices, guys, but they put them in an enclosure that even if there's an explosion, it will be contained inside the enclosure. And by the time the hot air will seep outside that enclosure, the temperature will be low enough that it will not ignite the surroundings. Will not ignite the surrounding. And this is the rules, guys, for cords. We just talked about the rules for when you use cords. The most extra hard usage, separate ground and conductor, be properly connected to the terminal, proper connection with that mesh to hold it, be supported by clamps in such a manner that no tension is transmitted to the terminals, that's a mesh. Be supplied with a seal to prevent the entrance flammable. Here's where the seal, you have to supply it somehow with a seal. Don't claim how they do that. But can I use a cord? Yes. Not to wire, just to tie to equipment. Here's my question for you guys. Can I use a flexible metal conduit to tie to air handling unit or a chiller? I hate to use that, or a motor in a class 1 Div 1 location? Yes, they can make an explosion-proof flexible metal conduits or liquid tight or whatever you need, but we can't use it to wire. We only can use it to tie to equipment. And everybody knows why we tie to equipment? Flexibility. You have a motor in a class 1 Div 1 and you rigid that motor. You know what happens when that motor runs? The whole building starts shaking. And the vibration, the noise, and ugly stuff.
What do you mean you can't wire?
You can't use MC cable to wire the whole building. The whole class 1 Div 1 or Div 2 and class 2 locations. You have to use rigid. Rigid. That's the wire. You can use THHL, but the conduit, you have to be rigid, intermediate, or on my cable if you want to go that far. Okay. Any question, guys, about the three classifications? Class 1, Class 2, Class 3, 501, 502, 503, 500 talks about all the stuff that we did. This is really the bread and the butter of it. For us designers, bread, all what we need to know what equipment you can use where, when. And that's summarize it. Using rigid or intermediate threaded with explosion-proof equipment at Class 1 Div 1 location is the worst of the worst with a group rating. Commercial garage. You have a commercial garage, guys, outside. You want to work a commercial garage. Very important. We encounter this all the time. A commercial garage is a hazardous location. If anything up to 18 inches is a Class 1 Div 2. So, Brad, if you want to avoid having an explosion-proof device, all what you have to do is just go 18 inches on a commercial, up to 18 inches higher, and put your receptacle. If you put your receptacle, then you can use this type of receptacle in an explosion in a commercial garage. If you lower it below 18 inches, you got yourself an explosion proof. We use this one, guys, all the time. If you have a commercial garage, ramp building and all this stuff, you see they move all the receptacles, especially. 18 inches is not hard to move. So you don't put any receptacles or any devices below 18 inches. If you have a pit in this area, it becomes a Class 1 Div 1. I don't think they can use the pits anymore in the commercial garages that they work on equipment or they lift the cars. But if you have a pit, it's a Class 1 Div 1, meaning avoid putting anything there, or it has to be explosion proof. Any question, guys, about the commercial garage? 18 inches, all over the commercial garage, Class 1 Div 1. A pit is Class 1 Div 2. Higher than 18 inches, no classification. So the lights in a commercial garage, does it have to be explosion proof? It's 18 inches, higher than 18 inches. You're good. Airplanes, if you guys work at the airport here, look at how they do them. Around the airplane itself is considered Class 1 Div 1 because of the jet fuel. Around, look at this is really the nicest picture that you can get in the code. Can you guys see all around the equipment? Everything is Class 1 Div 2 except this little pit here. I don't know if, again, I've been told that they don't use pits anymore. That pit is a Class 1 Div 1. So you bring your airplane to the airplane hangar, guys, and measure 5 feet around it in all these directions. Make sure if there's a fixture or whatever you have there, it's going to be explosion proof. So what they do, guys, they make it big enough that they can avoid this 5 feet clearances, and then equipment doesn't have to be explosion proof. Does not have to be explosion proof. But look at the height here. So does not have to be explosion proof. Does that make sense? So if you have an airplane hangar and your wiring does up to this area, I don't know how high is the airplane. This, let's just say 12 inches, 12 feet. Up to 12 feet, if you put any equipment around it, it's going to be explosion proof equipment. Any question about the aircraft hangars? When you put your lights, if you put a lighting fixture right in this area, I don't know why would you do that, like say 10 feet off the ground, this has to be explosion proof fixture or cascaded.
Let's say they needed full power up for some reason.
They have extra hard cord and yeah. It has to be like you need a cord to work on equipment. They plug it into a GFCI somewhere outside this area, so it doesn't have to be explosion proof. And they use extra hard cord with equipment rated to work on equipment. No arc fault. Just GFCI. Okay, gas stations. You guys have been on gas stations. In every gas station, 18 inches above the ground and 20 feet in every direction from the gas pump is a class 1 div 1. So if you're doing a gas station, avoid the following. Avoid putting anything, guys, below 18 inches and away 20 feet away from the pump. So if you have this, we have a couple of pictures here. This area, guys, 20 feet and 18 inches high. This is going to be a class 1 div 1. 18, that was on my master exam when I took it. So class 1 div 2, class 1 div 2. So what would I do, Spencer? Avoid putting anything less than 18 inches in a gas station. Move them up higher than 18 inches, then non-classified, you can use any wiring system. Your conduits in a gas station, guys, they're going to be rigid. If you enter this 18 inches, it's going to be rigid. Underground, they allow you to use PVC. If you're underground, you can use PVC. So there's a few, I think, any space within the pump enclosure higher than 4 feet. I don't know if I have the picture here, that 18 inches around here. No, I have the picture. You guys have the picture in your book. Do you? Yeah. If you look at page, it's nicer picture that I have, 262. There's a gas station, 4 feet around, 4 feet off the ground, and 18 inches around the pump itself is a class 1 div 8. Can you guys see that one? Here's a pump 4 feet off the ground, 18 inches around it. It's class 1 div 2. 18 inches above the class 1 div. No, I'm talking about the surrounding. The pump itself is a class 1 div 1. That's inside the pump. The pump itself is a class 1 div 1. The case of pump is here. I'm the pump, and 18 inches in every direction around me, up to 4 feet off the ground. That's class 1 div 2. A circle around it. And on the floor, guys, 18 inches off the ground, 20 feet around every pump is a class 1 div 2. Yes, sir?
For someone that's class 1 div 1, does it have to be serviced much more frequently? Does it have to be checked on? Is there requirements for, like, this has to be checked every 6 months or something to make sure everything's not?
The code, the NEC code doesn't talk about service. It doesn't talk. But I'm sure there's probably the gas station. There's a NFPA. Yeah, I'm sure there is. But not in NFPA, not in NFPA 72 or not in the NS50 code. I'm sure there's an article that tells you that you have to check them more frequently. Not NEC code though, that I know of. So this is your pump, my friends. If you have a spray and dipping process painting, this is a really nice picture. In the middle of the paint is a class 1 div 1, guys. And the surrounding it is a class 1 div 2 right here. And if you have a paint, it's class 1 div 1. Who cares? Now try to avoid. Here's when we design, Brad, hazardous location. Rule number one, avoid putting equipment in a hazardous location if you can. If I can put my panel in a non-hazardous location, should I choose to put it in a hazardous location? No. You put equipment in hazardous location, class 1, 2, or 3, guys, only if you have to, because it's expensive. Then if you have to, like, for example, I can avoid, if this is a class 1 div 1 location, I can put my panel outside and my disconnect outside, guys, and just bring the equipment itself here. So try to avoid using it. If you have to, then you have to follow the rules. Painting. Okay, good. This is just talks about if you have a seal, guys, how they have to be tight connection and all this stuff. That's all what I have for you. Any question, guys, about class 1 div 1? Summarize flammable gases and vapors, combustible dust, ignitable fibers and flyers, right? That's class 1, 2, and 3. Normal condition, hazard exists under normal condition, that's division 1. Division 2, abnormal condition. Pay attention when you are in class 1 and 2, guys, pay attention to the group of the gas, the vapor, or the dust. They're grouped. They're grouped, so it has to be a group. If you're in a class 1 div 1, Mr. Bab, you are an explosion-proof equipment and devices and lights. If you are in a class 2 location, you need dust-tight equipment. In a class 3 location, Brad, and class 2 location, the wiring is relaxed. You can use a lot of wiring, EMT and all this stuff. The hardest one is class 1 div 1 and 2. These are where you're rigid. You move to class 2 locations, and especially class 3 location, you can use EMT as long as you keep them tight, fittings, and all this stuff. Any question, my friends? Any questions? So please do the homework for that one. Let me